making these two, making that carbon really delta positive because all of the halogens are pulling electron density out. The carbonyl was already delta positive, and so the issue there is that two delta positives next to each other are going to make the system really unstable. But an unstable reactant pushes the equilibrium towards the product. So both of these will form significant amounts of hydrate, and in that case, their equilibrium lies towards the products. So that was kind of the essence of what the hydrate was about. And a hydrate is a hydrate. It just has two OHs attached to the same carbon. Whether it's an aldehyde or a ketone, it's the same. Does that make sense?
Yeah, thank you. Can we do, I don't know if this is what we just did kind of, but I saw on the one video you posted a reaction mechanism with the chlorohydrates.
With chloral?
I think it was like, it was a C double bond to O with an alkyl group and a hydrogen, or an R group, and then you add CH3OH to it.
Okay. Read that to me again.
It was a C double bond to O, and then on one side of the carbon was an R group, and on the other side you said it could either be a hydrogen or an R group. Like, we'll still get this, it's the same concept.
So what is on this side?
It was like, it was the C, but the double bond to O was facing up.
Oh, okay. All right, so what's over here then?
An R group.
Another R group?
Yeah, and then
Okay.
the other R, you said it could be a hydrogen, but like either one, it's the same like thing.
So what are we adding to that?
CH3OH.
Oh, CH3OH. Okay. All right. Yeah. So let me redraw that over here.
Okay.
Okay. So the mechanism for this reaction is going to be, we'll do it. It's going to be nearly the same as what I just did for the water. The only difference is that I can add now one or two equivalents of the alcohol to the ketone or aldehyde. So yeah, I'll write an R or an H, or I'll put something in brackets to indicate that this could be either a ketone or an aldehyde. So this is going to give us what is called a hemiacetal or a hemiketal, and then ultimately a ketal or an acetal. So if we're writing the mechanism for this, we're going to do exactly the same thing that we did before. I have my acid catalyst. I'm going to protonate the carbonyl oxygen. And we're going to do that a lot. So I'm going to end up protonating carbonyl oxygen to form the oxonium ion. And now instead of water adding, I'm going to add the CH3OH to that carbon. And if I use this resonance structure, that pair of electrons will go up to the oxygen. Otherwise, carbon's going to end up with 5 bonds. And so now I'm going to have my OH on the top and my OCH3 with the H on the bottom as an oxonium ion, and then I'm going to have my R there. Okay. Everybody with me?
Yes.
So basically, I just did what I had done before with an alcohol instead of a water. Then I'm going to lose the H plus, so this pair of electrons is going to go to the oxygen. And I'm going to lose my H plus to give me that species. So this is what happens when you add one equivalent of your alcohol. And this species in this case would be called a hemi-ketal. Now, you know it's a hemi-ketal, and after the exam, we'll go, after we learn a few more of these different kinds of compounds, we'll go through and name and learn how to name them. But this is a hemi-ketal because it's got an OH and an OR group attached to it. And for the other two groups, it has 2 carbons, which means over here, it came from a ketone. So that's why it's a ketal. If it was an R, it was a carbon group and a hydrogen, it would be an acetal. So this is the hemi because it's half of a ketal. So to continue on and add the second equivalent of the CH3OH, I need to either protonate this OH group, either protonate the OH group or protonate the OCH3 group. Now, if I protonate the OCH3 group, I'm going backwards to this product. And then if I lose the methanol, I'm going backwards to that product, or this product. And then if I lose the H plus, so that's why all of these steps have to be equilibrium, is because we can go backwards and forwards. So to make this continue to move forwards, I need to protonate now my OH group. And so I'm going to make an oxonium ion like I have in the past. And then I could ask you, I could say, okay, what's the next step? And someone would say,
lose the water.
thank you. You would lose the water. Okay, so now I have that carbocation. And now my second equivalent of methanol is going to come in and add to that carbocation. And then the final step is to lose the H plus. So now what I've done is now I've added 2 OCH3 groups to the carbon that was the carbonyl in the original molecule. And so this having 2 OR groups, but then coming from originally a ketone, that molecule would become the ketal.
Dr. Nichols, I think you said this on Monday, but I just wanted to double check that for an exam, you would tell us if like it was 1 or 2 equivalents, correct?
Yeah, I have to.
Okay.
Because let's say if I gave you this as a mechanism and I don't tell you, then unless you're overly ambitious, you would just add 1. So I will tell you exactly how many of these to add.
Thank you.
And for a mechanism, it's going to be 2.
For a mechanism like this, would you want us to have transition states too?
No. No, there's no mechanisms. There are no mechanisms that would be on this exam that would have transition states. They're
Okay,
all just
thanks.
they're all just intermediates. What else?
Do we have a specific topic list for the exam posted anywhere?
No, I was going to work on that today. The reactions will start because where we left off with the last exam was aromatic, not aromatic, anti-aromatic. So I know the reactions that we started with, the reactions that this will start with are in no particular order are, remember we talked about taking the side chain reactions. So the first one was, or one of the first ones was, what if I want to add a bromine to the benzylic position, which we talked about the difference, NBS, in this case, NBS or Br2 and light would work. One of the reactions we've used for doing the synthesis is that if we have any kind of alkyl group on the ring, if we use CAMNO4, we oxidize that to the carboxylic acid. So these were all kind of the reactions that we did before we started adding electrophiles to the ring. So then the other thing was if we used sodium with liquid ammonia, I'll put an R group here. We ended up forming the non-conjugated diene, and this was what was called Birch reduction. So those are the reactions that we would start with, but I'll put together a topic list. The bulk of the reactions is in that list of reactions and transformations.
Thank you.
Could you go over, so in the past exams that we've had, exam 3, spring 2019, could you go over the first mechanism that's in there?
Hold on. Do you have it with you?
I just have it pulled up on my computer.
Oh, can you share your screen with me?
I don't know.
Okay.
I don't think I can.
All right, then let me.
I can download it and then.
No, don't worry about it. Let's see if we can find it.
Okay.
Okay, so everybody's seeing my screen now? Somebody say yes.
Yes.
Okay, so let's go to home. And let's go to previous year's exams number. Which one is it?
It's the 2019 one.
Exam 3?
Yeah.
This one. Okay, mechanism number 1. Okay. All right, let me go back and pull up my whiteboard. So I could ask you to add any E plus to a substituted benzene ring. I just have to tell you where to add the E plus. So let's say I said, go ahead and add the E plus to the ortho position of this ring and then write all of the possible intermediate resonance structures. So what we would do is we already have a hydrogen here, so we would take this pair of electrons and add the E plus to it. And that would put the plus charge next to the oxygen. I could then take the pair of electrons and move it there to draw a second resonance structure. And this is what we did when we were doing 1,2,1,4 addition. Then I could take this pair of electrons, move it here to write a third resonance structure. So when I ask you to I'd ask you to add the electrophile, whatever it is. In that case, it was an isopropyl carbocation. So you can replace the E with an isopropyl group. I asked you in that problem to add it to the para position, but I could ask you to add ortho, meta, or para. So the idea is we're adding that to the ortho position. We're writing the 3 resonance structures that we get, but then remember that the OH group in this case, or actually any atom that's attached to the benzene ring that has lone pairs on it, the reason that that group was an ortho-para director is because there's a 4th resonance structure you can draw when you take this pair of electrons and move it down and then form the double bond to the oxygen. So that we would get that 4th resonance structure. And it was that 4th resonance structure that made adding the electrophile to the ortho, and you would get the same thing for the para, the more stable intermediate, so that it could go to, so that's why it added ortho and para to begin with. So then a final step, you could either take this pair of electrons from the hydrogen, let's just do it down here. You take this pair of electrons, move it there, you would lose H+, and then reform the aromatic ring. And then you would have your E there because you lost your H+. So that mechanism is, that's one of the mechanisms that was in our first lecture online, which was only last Monday, a week from this past Monday. So what I'm doing here is having you write the intermediate resonance structures and then show me the 4th resonance structure in this case that you would get for adding the electrophile to the ortho position. And you'll see variations on that in some of the older exams.
So the ortho-para directing ones, those will have 4 resonance structures, and then the ones that are meta directors will only have 3 resonance structures?
Yes.
Okay, thank you.
If it's a group that has either the atom with a lone pair, or if you put a benzene ring on there, then if you had the plus charge on the carbon, let's say you had an intermediate that looks like this, you could then move this pair of electrons down. So actually it would have a grand total of, I believe, 5 or 6 if it was another benzene ring. So that's a possible mechanism I could ask.
Did you say that it'll have 5 or 6, or like is there like a
So
definitive, or is it just like depending on it?
yeah, so this would have 3 just in this ring alone.
Yeah.
And then if we move this one, the plus charge will go here. Then if we move this double bond, it'll go there. And then if we move that double bond, so it'll have a grand total of 6.
Okay, thank you.
This is like earlier in the notes. I was just like flipping through them, but I don't know if this is gonna make sense, but could we do, there's like a problem here where you make a carbocation and you attach it to a benzene ring. Like, is that gonna be on the exam?
Sure. So, I mean, what we've been doing with benzene rings is we've been adding E pluses. And so that can be, that can be a carbocation that'll add into the benzene ring, like I just showed you by that mechanism. But what we could do is we can add in any carbocation we can substitute in the ring. The question was how we make the carbocations. So I mean, there are many ways. The first way that we learned was to do was to use aluminum trichloride or iron trichloride with an alkyl halide. But I also said you could react the double bond with H plus. So you would add double bond, you would add the H plus to the double bond in a Markovnikov fashion to give you the most stable carbocation. That could add into the ring. And you could also take a secondary or a tertiary alcohol and add H plus to that, which would then protonate the OH group. And then the water would leave. As long as this is secondary or tertiary, the water would leave to then give you a carbocation. Any one of those carbocations can add to the benzene ring. So actually in the list of reactions, I think I listed all 3 of these as ways to add carbocations to the ring. So that's how we can add a carbon group to the ring.
Thank you.
And the caveat here, and I'll just mention it because it was something that was missed quite a bit on, and I don't know, quite a bit, but it was more than once, that remember that if you try and do Friedel-Crafts alkylation with a straight chained alkyl halide, that you will not be able to add that straight chained group. So you will not get You will not get that. You will not get that. Instead, as the aluminum will come in and pull the chloride off, but then this hydrogen will shift over. So you'll end up doing a hydride shift to form always form the secondary carbocation. And that is one of the hydride shifts that I don't have to tell you will occur, because it will always occur. So a number of people tried to add just the alkyl group, the propyl group, to the benzene ring, and that will not work.
For the exam on Friday, you'll be posting it in the morning on Canvas, and then we'll submit it through Canvas again on Monday.
Yes. You can submit it at any time.
Okay.
It will go into, for Friday, there'll be a folder that says March 27th, exam 3. I'll be putting the exam in there, and you can either, if you have a printer, you can download it. It'll be in a PDF format, so you can download it, print it. If you don't have a printer, then you'll just have to sort of hand copy the exam, or just hand copy your questions like a monk would back in the old days. You'll write the question, then you'll write your answers, and then you can take photos or a scan, and then there'll be a Dropbox to upload them, and then I'll download everything, compile it into one PDF and grade it, and then it'll eventually go back up so that you can see it and download it. So that will all happen on Friday, and then it'll be ready to go at 8 o'clock in the morning. So whenever you get to it, you get to it. Just try and schedule sufficient time Monday and Friday and over the weekend. I know people are in different situations, but it's due midnight. It's due 11:59 on Monday. So you'll just do it and upload it. There'll be a little thing for you to sign that you worked on this on your own. But in essence, this is going to be open note. And there's no other way around that. And there'll probably be a little video with me saying, here's the ground rules, but work on this on your own, because you'll have to sign something that said you did. I can't get you to sign it in blood. So if you're the kind of person who's going to sign it and it's not truthful, there's nothing I can do about that. But I'm expecting you to work on it individually, but you'll have access to your notes, and you'll have access to whatever, because it's not going to be online. And that's fine. It'll be, in terms of the length of the exam, I'm getting emails left and right telling me not to overwork students. Hopefully I'm not overworking you, but there is your quiz for next Wednesday that's in today's folder, and it's due next Wednesday, is how's it going? So if you feel like this is an awful lot of stuff, tell me. But I'm gonna make it the same length as the 50-minute exam in classes. So I'm not gonna make it any longer. I'm gonna try and keep it to what a normal exam would look like. You may think it's longer, but I'm gonna try and keep it to the kinds of lengths of exams that are already online. Yeah, Maria.
I didn't hear this part, but are you giving this to us tomorrow to start or on Monday?
I'm giving it to you on Friday to start.
Okay.
So it'll be in each class's, it'll be in a folder, March 27th, exam 3. If I get it, I'll load it up ahead of time, but it'll automatically release at 8 a.m.
Okay.
So if you're in the 8 a.m. class, it'll release at 8. If you're in the 1 p.m. class, it'll release at 8. So you'll have Friday, you'll have Monday, and then you would also have anytime you can put in on it over the weekend.
Okay, thank you.
Friday I won't have any Zoom classes per se, because everybody's going to work on the exam. On Monday is going to be really awkward because people will still be working on the exam, perhaps. Well, but they will be. And so I'll be here during the 8 a.m. and the 1 p.m. But the video for today, the quiz for today, and the video that I put in Monday's folder, and the quiz for that will be due on Wednesday. So all of that stuff will be due on Wednesday, the following. I really have to have something for each day in order to account for, the class time. So in the video on Monday, I'm going to try to keep to less than to about a half hour. I'm just going to finish up chapter 22 and then we'll move forward.
Do we have any more videos to watch until Friday or no?
No, the Monday's video was the last video.
Okay.
I didn't record this one from the beginning, so I didn't catch the hydrate, but I caught it when I was doing the other one. I'm going to post after this. I'm going to post this afternoon. I'm going to post the morning lecture or the morning Zoom session, this Zoom session. I'm not intending for people to spend another hour watching videos, but I also am going to post the whiteboard notes so that if you take a look at the whiteboard notes real quick and you see something there like, oh, I think I need to look at that, then you can fast forward on the YouTube video to whatever, to wherever that section is and go over it. So that way everybody has access to what's going on in these sessions, even if they're not here or able to be here. And I'm not gonna, I guess if I was evil, I would block all that stuff out once I give the exam away, but you'll have access to everything. I'm not gonna restrict access to anything once the exam's available. So I'm trying not to create undue stress. Trying. That's why for the video, if you can tell me what you think is working, that's a totally anonymous survey for the quiz for Wednesday that's in today's folder. That quiz is totally anonymous, but this way I can get some feedback because this is only class number 1, 2, 3, 4, 5. This is only class number 5, and we still have quite a few between now and Easter and then after Easter. So they suggested that we do that. So I'm like, okay, fine. I'll get some feedback and just, you know, give me honestly what you're struggling with, what's helping, and I will try and modify things as we go along. And then I will be grading at some point today. I will start grading the online quizzes that are due at midnight from Monday's folder. So I'll start grading those, and then I'll finish those up in the morning, so that those will be graded, and you'll be able to see the answer key before the exam. Anything else? If not, I'll let you go. If you have any questions during the exam time, I will only answer clarifying questions. So, but up until that point, if you have any questions, I'll try and put together a list of topics. But it'll start after the after aromaticity, where we left off the last exam. All right, anything else?
No, thank you. Have a good day.
Okay.